Hi, my name is Monia Hossein, and this is my tech demo 3. So the first task is to graph x squared plus 2z squared less than or equal to y less than or equal to 18 minus x squared, and restricted only by the left half of the 3D space. So you can go ahead and plot it in Desmos. 2z squared equal to y equal to 18 minus x squared, and to cut this in the x axis region, we will do curly brackets x less than or equal to 0, which will only restrict this curved shape to the left half of the 3D space. So this is our final solid. Moving on to the next solid, we are given that p is equal to 2 and rho is equal to 2 and rho is equal to the square root of 2, which means there's two spheres, and r equal to 1, so one cylinder and two spheres. I am going to be using CalcPlot 3D, and since I'm using parametric surfaces, theta and phi will be in terms of u and v. So u is equal to theta and v is equal to phi. So if we have our conversions of spherical coordinates, we will have x of uv equal to rho times sine v times cosine of u, and then y of uv equal to rho times sine v times sine u, and z is uv equal to rho times cosine of v. And now we need to find our bounds. So rho is from square root of 2 to 2, and then theta will be from 0 to 2 pi. Okay, this bounds. And phi is from, we need to find phi. So we are given r equals 1, the cylinder. So to translate this, we are going to do r equals rho sine phi greater than equal to 1. Then we're going to continue solving for phi. And we have phi. That should be 1 over p. It's equal to sine inverse 1 over p. And we know that this is from 0 to pi. And now to include this, it is going to be sine inverse 1/2 pi sine inverse 1/2. And why we're doing 1/2 is because we want to capture the entire region for all of the rho from square root of 2 to 2. So we use the widest range of phi that satisfies all. So we're going to use 2. And so this will continue to give us pi over 6 to 5 pi over 6. So these are our bounds. And now we can continue with plotting. Similarly, you could also do this in Cartesian coordinates. So basically, I just did the sphere formula and put in the radius 2. Um, I'm sorry, 2 squared, as you can see here. And, sorry, square root of 2 will give me 2. And 2 squared will give me 4. And then I have the cylinder formula. And then I solve for z so that I can know where the cylinder will be capped in the two spheres. So essentially, there's going to be this hollow cylindrical shape inside the two spheres. And I will show this as well. So let me go to CalcPlot 3D. So I have the inner square, which is square root of 2, which we had our formula as rho times sine v times cosine u. But since there's no rho constant, we will go ahead and put in square root of 2, and then the other one is 2. And then we have our theta as u, so 0 to 2 pi, and our phi is pi over 6 to 5 pi over 6. And we will get this inner sphere. I will get rid of this right now. So here is my inner sphere with a hollowed out cylinder. And here we have the same bounds, but instead of square root of 2, we have the other sphere being 2, since rho is the radius. So I will go ahead and put this in, so you can see that the outer sphere also has a cylindrical hollow. And now to show by Cartesian, okay, I will get rid of this. Cartesian coordinates, all I did was from 2x squared plus y squared plus z squared go to 4. And then I am going to add the cylinder with the radius 1 plus y squared greater than or equal to 1. So I'm going to extend to 3D. So that's why I used CalcPlot 3D, because you can see the cylinder, the hollow cylinder. But for Desmos, you have to see it like this, and it covers the whole region. But yes, essentially the cylinder, the hollow cylinder going inside the spheres. But this one does a better demonstration. For the last task, I did a linear transformation, which I basically did the inverse matrix. So first, I separated u and v into giving me this matrix that I can use to find the inverse of t. So, which gives me 1 half, 1 half, 1 half, negative 1 half. And I take the det, which is negative 1/4 minus 1/4, which will give me negative 1 half. And we're doing 1 over the det, which is negative 2. And then we have dA and negative c, negative b, which will give me this matrix, 1, 1, 1, negative 1. And then here I'm taking the points that were given and doing matrix multiplication, which will give me the transformed coordinates, negative 1, 1, negative 1, 1, 1, and negative 1. So I will go into Desmos, and I will be using the polygon function so that it can draw the square instead of just giving me points. So I will plot down the given points, which is -1, 0, then 0, 1, then 1, 0, then 0, -1, which will give me this diamond shape. Technically a square. And I'm going to do the polygon function again. And this time with the plots I found, or the points I found. So 1, 1, 1, -1, sorry. Then -1, -1, then -1, 1. And here I have the transformed square. Thank you for watching my video.